Hello my friends from all over the world, talking to Israel, your teacher from Brazil. Welcome back to my channel, my friends. On this video, I'm going to talk to you about a very cool area, which is the area between the function square root of x and the function x squared, but from 0 to 1 only. And why did I choose this specific range, this specific interval here? I'm going to show you why I chose this specific range, because it is very interesting what happens here between 0 and 1. Okay, when we think about the function square root of x, we always think that this result, the solution, is going to be a number that is less than the original number. And when we think about the function x squared, we think that the number that's going to come out is a number that's always bigger, it's always greater than the original number, but it doesn't hold true for the entire range, for the entire set of complex numbers. Okay, and I'm going to show you that from 0 to 1, actually the square root is going to be bigger, it's going to be a greater number than the x squared. First of all, let's take a look at this number here, 0.5. Okay, in Brazil we use a comma here, but in the United States and other countries they use a dot here. Just let's suppose that this is a point here, and then it's going to be okay for everybody. All right, so 0.5 squared is not a number that is less than 0.5. Okay, the square root of 0.5 is 0.707. Okay, this is a number that is greater than this original number. And for a number that is greater than 1, the square root of 4, for example, is 2. Okay, so we know that from 0 to 1, actually the square root of the number is a number that is greater than the original number. Okay, and this is what permits us to calculate an area between the function square root of x and the function x squared. Okay, my friends, so now how are we going to calculate the area between these two functions here? First of all, what we need to do is to understand what is an area. Okay, the area, how can we calculate the area? First of all, what we can do is to calculate the area below the function x squared. Okay, I'm going to quickly draw it here, and I have the function, the square root of x first. Okay, this is going to be the point 1 and 1. Okay, and we are interested in the area below the curve. Okay, and now I'm going to draw the second function, which is the square x squared 1 and 1, and we are interested in the area below the curve. Okay, if we calculate this and subtract this, we have the area that we wish to calculate, isn't it, my friends? I know that you are smart guys, and you know that what I'm doing here is going to produce exactly what we want, isn't it, my friends? So let's go forward. Let's go ahead and calculate what we wish to calculate, my friends. Okay, for you guys that know how to integrate, this area here is going to be simply the integral from 0 to 1, the integral from 0 to 1 to the upper, from the lower limit to the upper limit, from the lower limit to the upper limit. But who is the upper limit? The upper limit is going to be the function that represents a greater number. Okay, so the greater number is going to be here minus the lesser number, okay, which is the square root, it's x squared, okay, it is x squared. Then if we integrate this, we're going to arrive at the solution that we wish. All right, my friends, isn't that what we want to calculate? So this is what we're going to do. We can break it apart, and it simply becomes this. Okay, it's simply becomes this. The area then becomes the integral from 0 to 1 of the square root of x dx minus the area from 0 to 1 from x squared dx. Isn't that, my friends? I know that you are very smart guys over there, and you can certify that what I'm doing is right, isn't it? Okay, so how do we calculate this? Because what we want is to calculate the area below this curve here, and we want to take out, we want to subtract the area below this curve, and what we are left with is only the area that we're interested in, isn't it, my friends? So the solution is going to be the integral of this is going to be the integral of x 1 raised to the power of a half dx minus this, okay, x squared dx. Okay, so how do we calculate that? Do you guys know how to calculate this? Okay, it's gonna be easy. It's gonna be easy. We add 1 here and divide by the number that results, isn't it? Isn't it, my friends? Let's go. Let's go and do that. Let's go and do that. Just that. Okay, so it's going to be e is going to be the integral from 0 to 1 of x raised to the power of 1 divided by 2 dx minus from 0 to 1 x squared dx. So I add 1 here and divide by the number. Then the area is going to be equal to x 3.5 divided by the same number, 3.5. And minus, I add 1 here, it becomes x cubed divided by 3, and I evaluated this from 0 to 1. My friends, we are almost arriving at the solution. Okay, then it's gonna become a is gonna be equal to 2/3 of x, like that, from 0 to 1 minus x cubed divided by 3 from 0 to 1. Okay, if we put 0 here, it becomes 0. If we put 0 here, it becomes 0. So what we can only do is to put 1 here and put 1 here, and it becomes 2/3 minus 1/3. Isn't that? Isn't that? Are you following? Okay, did I make a mistake? Okay. If I made a mistake, you please correct me. And the area is then 1/3. 1/3. The area is 1/3, my friends. This is the video that I wanted to show you. I wanted to calculate with you the area of this function here below these two functions, x, the square root of x and x squared. And I hope you guys enjoyed it. Goodbye, my friends.